some terms like what is the swept volume, what is the engine capacity, what is stroke, bore, these things. So far we stand on a place where we are about to start learning about the strokes and about the cycles of the engine. So we will start with a 4-stroke spark ignition engine. What basically this 4-stroke spark ignition engine is, in any engine, there are 5 processes that are needed to be completed in order to produce power. That will be suction, and then compression, and then ignition, and power, and exhaust. These 5 processes are required to be completed in any engine, be it your spark ignition engine, be it your compression ignition 4-stroke or 2-stroke, whatever. So the difference between 4-stroke and 2-stroke is this only, that these 5 processes in 4-stroke engine are completed in 4 strokes, and in 2-stroke engine these are completed only in 2 strokes. Okay, so this is why they are known as 4-stroke engine. Or yes. Please please mute yourself, whoever is talking. Okay.
Yes, I think it's sorted.
Let's go on with this. So 4-stroke spark ignition engine we are going to study here. First of all, we will understand what are these strokes and what are these processes and what exactly happens when we talk about any stroke or any process. So you see this image over here. This is the schematic of the 4-stroke spark ignition engine. So the first stroke, when the piston is at bottom dead center, you see, then over here this valve has opened. This is the intake valve. So we understood from our previous discussion that the valves open only when they are allowed to. So this is a cam and camshaft mechanism that operates the valve timing, that lets the engine operate its valve whenever the timing is arranged for, and the duration. Okay. Like for how much duration it is to be kept open, and after that this is the exhaust port. This works as the similar way. So we will see, okay, when the piston is at the bottom dead center, the fuel will start coming in. So this stroke will be known as suction or intake stroke. Let's not go on spark ignition and compression ignition. There will be a slightly change in this particular stroke. So over here, there will be the air and fuel coming from the intake manifold, and it will be inside the chamber. As we understood, first part was the cylinder block, and inside the cylinder block there was the cylinder fitted, and this area, this slight blue or what the color is, this area is the combustion chamber, or this space you can say. So when this fuel comes in, and this is basically compression stroke. So as soon as this area reduces, this piston starts coming up, and as soon as it approaches the top dead center, the spark plug, or if it is the compression ignition, the self ignition temperature will be reached. So in this case, since this is a spark ignition engine, so this fuel is to be burned by a spark, and as soon as it reaches the top dead center, this spark will happen, and this spark will create an explosion of the fuel, and that explosion will push the piston down. And at the same time, when the piston goes down, this exhaust or this emission stroke of the gases will pass, and this will be the third, will be the power stroke or expansion stroke. Expansion means due to the blast or due to the explosion, this piston is pushed down. So this is power stroke or expansion. Expansion is that area, this particular area is being expanded because of the push of the piston. Okay. Then let's say this is a power stroke, and then soon after that, this valve will open up and these exhaust gases will pass through this exhaust manifold. All right. So these are four cycles. First of all, the suction will happen or intake will happen, and then compression will happen, and then this power stroke will happen, and then this exhaust stroke will happen. So these are four strokes, and in these four strokes, the piston moves twice up and down, or the crankshaft, the crankshaft has to rotate 720 degrees, and the revolutions that crankshaft is making are 2. So let's just summarize it. What is it? So we are talking about a spark ignition engine. Spark ignition engine is that which runs on the gasoline or petrol, and a spark plug is used to ignite the fuel. So in a 4-stroke engine, the cycle of operation is completed in 4 strokes of the piston and 2 revolutions of the crankshaft. So these are the 4 strokes that we were talking about, and that correspond to the piston. And in these 4 strokes, the crankshaft, this shaft rotates 2 revolutions. So 4-stroke, 2 revolutions. And in each stroke, the crankshaft rotates 180 degree. So we have 4 revolutions. So in total 4 revolutions, the crankshaft will rotate 720 degree, or each stroke consists of 180 degree of the crankshaft rotation. Hence 4-stroke cycle is completed through 720 degree of the crank rotation. And these 4 strokes are, first of all, suction or
excuse me, sir, your mic is muted.
I didn't mute it though. All right, no issues. Okay. I hope it is fine now. So this first stroke, the intake stroke, then this second stroke, this compression stroke, then this third stroke, power stroke, and then exhaust stroke. So we'll understand it with the help of a video. This is the piston and it is going down. And as soon as it is going down, see, initially you will see that fuel is coming inside. This blue area is the combustion chamber. So the fuel has come inside now, not only the fuel, but the air fuel mixture. And now the piston started going up. As soon as it goes up, the compression happens and temperature rises up due to the compression. And soon as it reaches the top dead center, a spark is going to be just created by the spark plug, and this will cause the blast to happen or explosion to happen. Now this blast or explosion, it is pushing the piston downward, and after the blast you will see that there are the emission gases or the exhaust gases, and in order to create the next blast and in order to let the new charge or new fuel come in, these gases need to be taken out of the chamber. And how is it done? This exhaust valve opens up and the exhaust gases pass. So this is how the cycle completes. Now again, it will just new fuel will come and it will run for another cycle. So this cycle go on, and this is how your 4-stroke engine work. So there is a slight difference of understanding. In spark ignition, the air and fuel mixture comes in through the carburetor. And if there are no carburetors, since like in modern cars technologies, even the petrol and the spark ignition engines are having the injection system. So that injection system allows the fuel and air to come in. And this air fuel mixture also can be given by the carburetor, though the old technologies had the carburetor to mix the air and fuel to basically regulate this supply of the air fuel mixture. So it is going to come from this intake manifold. It is going to be sprayed over here, and this piston starts traveling upward now. So as it travels upward, this fuel and air mixture, it will be compressed, and it will be compressed to certain extent, and as soon as it reaches the top dead center, the spark plug is instructed to create a spark, and in third, the explosion will happen, and that explosion will push the piston downward, and this is the third stage. And as soon as the piston goes downward, these exhaust gases are taken away from the this exhaust valve, and this goes on, and the cycle completes. So in one cycle, understand that the piston has 4-stroke and the crankshaft revolves twice. So these are things that we need to understand. So we'll relate it with the this compression ignition engine also, and with the 2-stroke engine also. Let's go ahead and let's see what is the 4-stroke compression ignition engine. So though the cycles or the processes or the strokes, they are same in here also and in there also. There were 4 strokes in the spark ignition. There are 4 strokes in the compression ignition. There is only one change. That change is, first, through the inlet, air comes in. So suction of air is done, and in place of the spark, there is an injector over here. So first, air is coming in the first stroke, suction of air happens, and then in the compression stroke, this air is compressed, and since the air after the air is compressed, its temperature will be increasing. And at the same time, when the piston reaches the top dead center, at the same time, atomized fuel is sprayed into the combustion chamber. Atomized fuel means very fine droplets of the fuel. So it will be sprayed into the combustion chamber. And since it is the hot air, and this diesel fuel, it has relatively lower self-ignition value. So it will self-ignite itself, and a blast will happen, and that blast will push the piston downward. Exhaust gases will pass from the exhaust manifold after the exhaust valve has opened up, and this is how the cycles are going to be completed. There was only one difference of the intake suction or intake stroke. Earlier, having air fuel mixture inside. Now we are having only air coming inside, and then after this air is compressed in the compression stroke, we will spray the fuel through the injector. So injector is a device that sprays the fuel a very small tiny droplets, and it atomizes the fuel. So the spray is so fine that it is sprayed over the hot air, the fuel. So the 4-stroke compression ignition engine is almost similar to the 4-stroke spark ignition engine, but it operates at a much higher compression ratio. The very first thing is the compression ratio in the spark ignition engine is very less as compared to the compression ratio of the compression ignition engines or the CI engines. The compression ratio of SI engine is between 6 to 10, and for the CI engine, this value is 16 to 20. So in the CI engine, during the suction stroke, air instead of the air fuel mixture is inducted, as I said earlier also. In SI engine, air fuel mixture was incoming through this intake manifold, and in this CI engine, only air is coming in the first stroke, in the intake stroke. And due to the high compression ratio at the end of the compression stroke, the temperature is sufficiently high to self-ignite the fuel, which is injected through the combustion chamber. In the second stage, when the compression happens, this air is compressed. This air has a high temperature. temperature now, and at the same time the injector is spraying the fuel inside the combustion chamber, and blast will happen or a fire will take place, and this explosion is going to push the piston downward. And similar to the exhaust stroke of the SI engine, this valve will open up, the exhaust valve will open up, and these exhaust gases will pass through the exhaust manifold, and the cycle will continue. So same as rest of the cycle is same as the spark ignition. There is only two changes. One, the intake, and second is there is no spark plug. There is the injector in place of the spark plug. So we will understand this again with the help of the animation. How does it happen? So this was the video that I showed you in the morning session when I was discussing the part of engine. So I'll again explain everything. These are the parts of the engine attached. And now what happens is that intake stroke happens. So first of all, the air will come inside. So these are the valves, intake valve, exhaust valve, and these are the cams. So they are mounted on the camshaft. Now you see, this is how these are operating. So let's go a little back. So you see, these cams are rotating, and the rotation of these cams is opening or closing the valve. The air that is coming inside the combustion chamber now, only the air, and piston is going downward. Air is coming because of the downward movement of the piston. A partial vacuum is created, and that invites the air inside. As soon as the piston reaches the BDC, bottom dead center, air, this inlet valve closes, and the air is completely trapped inside. Upward, and this will compress the air, and the compression will result into increment of the temperature. So at the same time, there is no air coming. Let this stroke be passed, then in the next cycle, the air will be coming for the next cycle. So this is being compressed now. And as it compresses, its temperature rises up. And as soon as it reaches the top dead center, there will be a fine spray of the fuel, and this will create a self-ignition of the fuel. These are the very fine droplets. The size is very fine. If you happen to see it in real, you will be amazed to see the size of the droplets. And this is causing the explosion or the fire, or this is how the power stroke happens. And as soon as the power stroke happened, the piston will be pushed downward, and this, when it starts, it almost reaches the BDC, the exhaust valve will open up, and the exhaust manifold, and this is how this cycle will be completed. So you see, this is the crankshaft rotating, and this is the connecting rod that is pushing or pulling the piston. And now the exhaust stroke. Now there are the emission gases trapped inside this combustion chamber, and they will be having high temperature and high pressure. So various types of gases, carbon monoxide, carbon dioxide, NOx. So these gases are the emission gases. Now these emissions are taken away from the exhaust manifold, and this is how your cycle gets completed. So there are total 4 strokes in one cycle. This was related to the compression ignition engine. Now we have the 2-stroke engine. As we saw that piston moves 4 times, or piston has 4 strokes, and still there are only 2 revolutions of the crankshaft. So that means the power produced is relatively low. I mean, if we can just remove these 2 steps and we can just complete these cycles or the processes that are needed to be completed for the exhaust and also the power stroke, so that will be easy for us. So basically, in 4-stroke engines, there is 1 power stroke for every 2 revolutions. 1 power stroke for every 2 revolutions, as I said earlier also. Four-stroke engine, irrespective of its fuel type or gasoline or CI engine, this piston will have 4 strokes, and the crankshaft will rotate 2 revolutions. All right, so that means 1 power stroke and 2 revolutions. So there are 4 strokes, and in these 4 strokes, there is only 1 power stroke. So if we just can decrease these strokes, so that basically in 2-stroke engine, what is the scenario? The 2 strokes are reduced, and only 2 are left. And those stroke, though the processes are same, suction of the fuel, compression of the fuel, power stroke, the spark or power stroke, and the exhaust, the processes are same in these 2 strokes. But what has changed? The strokes and the position of the intake and exhaust manifold. This has changed. So let's see. In a 4-stroke engine, there is 1 power stroke for every 2 revolutions of the crankshaft. There are 2 non-productive strokes, the exhaust and suction, which are necessary for flushing the products of the combustion from the cylinder and filling it with the fresh charge. So basically, what we are trying to say is that if we somehow can manage these 2 strokes, which are basically non-productive, we are not having any power during these strokes, but yes, they are necessary to be completed. They are mandatory to be completed, because then only after exhaust only the new charge will come up into the combustion chamber. And if this purpose could be served by an alternative arrangement without movement of the piston, it is then possible to obtain a power stroke for every revolution of the crankshaft, increasing the output of the engine. So what we did is we just reduced these 4 strokes, and we brought 2 new strokes into the light, and these 2 new strokes are upward stroke and downward stroke. You will see that engine construction in this case is changed a little bit. Earlier, we used to have one side the intake manifold, one side the exhaust manifold. But now you see that this is the intake manifold and this is the exhaust manifold. So you see that piston over here, if you can see, at this point of time, the intake manifold is closed just by the piston itself. And as soon as the piston travels up in the second diagram, you will see that the exhaust manifold is uncovered by the piston. So you see the piston only itself is working as the closing and opening for the exhaust and intake manifold. Earlier, we used to have valves for this operation. So only one valve will open, intake valve will open, so intake will happen, exhaust valve will open, the exhaust will happen. So over here, this piston is covering that thing. So now the engine construction has changed, but the engine parts are almost similar. Like there is a piston, there is a connecting rod, there is a crankshaft, there is the cylinder block, cylinder head, crankcase. Everything is almost similar. There are a few things like the cams, camshaft, and valves and valve train. They are not present. So we will see with the help of the animation how these two strokes happen. So first of all, again, we are going to understand the key components of this two-stroke engine. First of all, engine head, then engine block, then oil sump or crankcase, you can say, then a transfer port. And what is a transfer port? I'll just on the way when the time comes up, I'll explain what is the transfer port. That there is inlet or intake port and there is exhaust port. Then after that, we will see what components and how they are arranged. So this is a piston, and over the piston we have the compression rings, and then we have the piston pin. Then there will be a crankshaft connecting rod. So yesterday, in the morning, I told you that there is a small end of the crankshaft connecting rod. There is a big end of the connecting rod, and this is the crankshaft, and this is a spark plug. So we'll join them together in the construction. This is the piston we have connected. And now we will connect the connecting rod with the piston and the crankshaft. So this is the connecting rod and it will be connected with the help of the gudgeon pin or the piston pin. So this crank is connected with the help of the crank pin. And then we will place the spark plug over here. All right. Now you see this is the exhaust manifold. This is the intake manifold. Now there will be two strokes. In working, there will be two stroke. So there is one upward stroke and there is one downward stroke. So in upward stroke, two processes happen, suction or intake. So if you remember in 4-stroke engine, first suction was happening, then compression was happening, and we called them two separate strokes. But in this, we called it as upward. And in this upward stroke, only two processes are happening, which is suction and compression. So you see how does this take place? So now you will see that this intake of the fuel is happening, and this is where the fuel is coming from, the intake manifold. The fuel is being stored inside, and as soon as the because now at this point of time there is already fuel inside the combustion chamber, and we will see how it is being compressed now. And after the compression is done and piston reaches the top dead center, a spark will happen, and that spark will ignite the fuel and a blast will occur, and that blast will push the piston downward. So now comes the downward stroke. So two processes are completed previously. Process 1, the suction, and process 2, the compression. Now downward stroke, there will be again two processes, power and exhaust. So as soon as spark happened, this blast due to the spark, piston started coming downward and exhaust started going. So that this was the power stroke when the spark happened, and power stroke in case of the 4-stroke engine. But in 2-stroke engine, this is the downward stroke, and in downward stroke, two processes are happening. One, the exhaust or the power stroke, and one, the exhaust stroke. So you see, as soon as the piston started coming downward, this fuel started going up in the combustion chamber. And when the cycle goes on, you will see that the again upward stroke will start. Now this downward stroke is completed since one cycle has completed. Now again the upward stroke will start, and this upward stroke, you see this fuel came inside, and now when this upward stroke is happening, you will see that there is some amount of fuel that is going out from the exhaust manifold or from the exhaust port. So this is known as the scavenging, or the stroke scavenging or fuel scavenging, you can say. In two-stroke engine, you might have seen like in old scooters or anything, if you might have seen, with the smoke, with the exhaust gases, there was some unburned fuel that was coming out of the exhaust. So that is known as the scavenging. And it can be minimized, but it cannot be prevented completely. As see what happens, because there is no valve to close, there is no arrangement to close this from here, because as soon as the new fuel started coming inside this combustion chamber, there is nothing that can close itself. So if there is any valve or any operation or anything that can close it, so that resulted into a better efficiency. And because this is the unburnt fuel that is coming out of here, you see, this is how it is happening. A little amount of fuel, it goes out. Power coming down, downward stroke, then again upward stroke. In upward stroke, intake happened first, then compression, then in downward stroke, power, then exhaust, and the cycle goes on. Now you see, there are two processes, two strokes, and in these two strokes, the piston revolves twice. And in 4-stroke, piston used to revolve only these 4 strokes and only twice. Now see an actual thing over here. That was the animation. See this section view of the engine. This is again the same thing. From here, the intake is happening and compression is happening. And as soon as the fuel will reach, the piston will reach the top dead center, a stroke, a spark will happen, and that will cause the piston go downward, and the exhaust gases will pass on from here. And this is how your 2-stroke engine will work. So now we are ready to compare the 2-stroke engines and 4-stroke engines and the SI engine and the CI engine. So this is how this cycle works. Now the piston construction in 2-stroke engines is slightly different than those of the 4-stroke engines. You will see that piston in the SI engine and the CI engine is leveled over here. There is some gap at the top, there is some slot left intentionally, but you will see that it is bulged over here. So this is intentionally done in order to keep the interior of the engine functioning properly as per the requirement of the design. So this is designed in such a way. Now going further, we have the comparison of SI and CI engine, and the comparison is done based on the cycle, based on the fuel, introduction of the fuel. Introduction means how the fuel is coming inside. Then based on the load control, type of ignition, compression ratio, speed, thermal efficiency, and weight. So SI engine cycle is Otto cycle or constant volume heat addition cycle. This is heat, not head. So the compression ignition or the CI engine will work on diesel cycle or constant pressure heat addition cycle. Then type of fuel in SI engine is gasoline, a highly volatile fuel, which is self-ignition temperature is in which self-ignition temperature is very high. And in CI engine, diesel, a non-volatile fuel, and the self-ignition temperature is relatively low as compared to the gasoline or petrol. Then introduction of fuel, how the fuel comes in the SI engine. A gaseous mixture of air fuel is introduced during the stroke of suction. As we saw, a mixture of air and fuel comes inside. And in the compression ignition, first the air comes inside, then the fuel is injected. The fuel is injected directly into the combustion chamber at high pressure at the end of the compression stroke. Then comes your load control. The throttle control the quantity of the air fuel mixture here. The throttle when when you increase the RPM, you do nothing but you provide more fuel. So through and in order to get more power from the engine, you need to increase the supply of the fuel. So basically, more power will lead into more load control. You can be able to control more load at more throttle. So throttle is basically nothing but to provide more air and fuel mixture to the combustion chamber, so that a greater power stroke can happen. Then quantity of the fuel is regulated and the air quantity is not controlled, and it happens through the injector. So there are a lot of injection systems like common rail, diesel injection, and there is multi-point injection system and multi-point fuel injection, MPFI, CRDI. Okay, so there are a lot of, or there is in SI engine also there is DTSI, digital twin spark ignition. So there are many technologies to increase the efficiency of the engine or to decrease the amount of unburnt fuel inside the combustion chamber. So in SI engine, the ignition happens due to a spark plug, and in CI engine, ignition happens due to the self ignition, because the self ignition temperature of diesel is relatively low and the compression ratio in SCI engine is high, so that compression of air is done at a greater rate, and the temperature of the air after it is compressed is huge, and it is sufficient to self ignite the fuel that is sprayed over it. So compression ratio in SI engine is 6 to 10, and the compression ratio in CI engine, it is 16 to 20. Then speed. Usually SI engines are used for high speed engines, high speed purposes, and relatively low speed engines are used as CI engines. So there are obvious reasons, because the CI engines have large number of vibrations, though they are heavier also as compared to the SI engine, as they have to encounter more vibrations, more forces, and more ununiformed cycles. So then there is thermal efficiency. The SI engines have lower thermal efficiency, and CI engines have higher thermal efficiency. Then there is weight. The SI engines have lower weight, and the CI engines have higher weight. So these are few parameters on which you can compare the spark ignition engines and the compression ignition engines. Now, the comparison of a 4-stroke and a 2-stroke engine. So let me just rewind the discussion for you. So over here, intake, exhaust, then there was a spark or injector over here. So from here, the exhaust will happen, and from here, the intake will happen. Okay, then there is piston over here, and this piston is connected to the crankshaft through a connecting rod, and a crankshaft is nothing but a shaft that has the output. If I would be showing you the crankshaft, it would be something like this. So as soon as this piston comes down, so this crankshaft is going to rotate. This crank is going to rotate, and with this rotation of the crank, this shaft is going to rotate. So this shaft is then connected to the gearbox. If you see your engines, you will see that over here is some output coming. There is from engine, there is the sprocket attached over here, and then it goes to the tire. In case of two-wheeler, I'm talking about. So you will see that you will see this sprocket rotating. This sprocket rotating. What actually is rotating? That is the output shaft of the gearbox. And if I just draw this, this is one shaft. On it, there are gears attached. And this is one shaft. On it, there are gears. So this is crankshaft basically. And this is your gearbox shaft. So the output that is shown over here in the bike engine, this is not the crankshaft. The crankshaft is inside the crankcase only. This is the gear out shaft of the gearbox. And this is the crankshaft actually. So the crankshaft is directly connected to the piston. And this rotation of the reciprocating motion of the piston, it rotates the crankshaft. And the crankshaft is again connected to the gearbox shaft. And these are various gears like gear 1, 2, 3, 4, and so on. So if it is in contact with this gear, this will rotate and this will produce the power. If it is in contact with this gear will produce power. So tomorrow I'll show you the details of this, how the gearbox works and how the crankshaft transfers its power to the various gears. So now you just understand that this is the system of power transmission in 4-stroke engine. So now you see that there are 4 strokes and 2 revolutions. And in this section, there is one exhaust, one intake, and over here is the piston. And this piston is going to cover this part. So if it is moving upward, it will cover this exhaust part. If it is a bottom part, it will cover the intake part. And then there is a transfer port. So basically what happens inside this engine, the fuel comes in and it stores inside the fuel sump. And then there is a transfer port. Transfer port is like when the piston comes downward, the fuel starts traveling upward and it is sent inside the combustion chamber from here. So this is the work of the intake port. Now, since the piston shape is such that when it will go upward, it will compress this fuel and the spark will happen from the spark plug and this cycle will complete. So over here, 2 strokes and 2 revolution. So basically 1 revolution per stroke. And over here, 1 revolution per 2 strokes. So if we have the same amount of same size of engine, let's say 150 cc 4-stroke and 150 cc 2-stroke. So let's say power in this is A HP. And so in this power is theoretically twice in here. It will be 2A HP. So this is why you might now know that okay, why the 2-stroke engines are more powerful as compared to the 4-stroke engines, because there is power stroke happening every one revolution happening per stroke, and in 4-stroke engine the revolution of the crankshaft happens in 2 strokes. So Relatively, the two-stroke engines are more powerful, but yes, they have their own disadvantages, and because of that only they are discontinued and are not used widely in the applications. Now we'll see what is a spark plug, because it is a very important part that needs to be discussed, and the spark plug and the injector basically. So we'll first see what is the spark plug. So spark plug is an electrical component of the engine that actually ignites the fuel in spark ignition engines. So you see, this is a typical design of a spark. You see, this is some gap over here, and this gap is intentionally kept, and it is varied as per the application, as per the size of the engine. And these spark plugs are designed for the specific size of the engines, like 50cc, 100cc, 110, 125. So it is not like any spark plug can be used in any vehicle. So two-wheeler spark plugs are different, four-wheelers are different, and so on. So we'll see what is a spark plug. So basically, in a very simple language, we can estimate it to be something that creates a spark that basically ignites the fuel. But what is the construction? What is the engineering behind it? So it has many parts. The part sections are listed in this drawing: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are the parts. So this insulator, part number 1, this section, this is your insulator. You see, from here, you will see down till down here, this is the insulator. And what is the insulator? This insulates the terminal, center shaft, and center electrode from housing, preventing the escape of high voltage from the electrodes. And what are the components just we named? Insulates the terminal, center shaft, and center electrode. Terminal, center shaft, and center electrode. This. So these parts we will understand. Now this is the insulator part. From over here till here, white section. Now what is terminal? Part number 2, this terminal. The terminal is connected to a high tension cord through which the high voltage current from the ignition system flow. Okay. Now this is the part which is connected to your cable. So if we talk about a two-wheeler engine or a bike engine basically, so you will see that the spark plug is visible to you from the outside. And if you happen to pull up the plug, you will see this part. So this part is basically a connection that is connecting your high voltage power line from the ignition coil, and it is connecting the rest of the infrastructure inside it. So this is basically a terminal. As soon as you connect the cable of the ignition coil with here, so the circuit will be completed. So this is terminal. Now part number 3. Part number 3 is this part, the ring packaging washer. So it is hardly visible over here. This is washer actually makes insulator and housing fit tightly to each other and maintains the air tightness. Then the fourth part is the center shaft. There is a shaft inside it. So if you happen to break or cut any spark plug, you will see that there is a center shaft. The center shaft connecting the terminal and the center electrode. This shaft is made of steel and has the role of allowing the high voltage current to flow from the terminal to the central electrode without loss. So basically, this current is supposed to pass from this terminal to this point, and this will happen through the center shaft, or also known as the stem. You will see it over here, and this is a steel rod basically. Then part number 5 is housing. You will see this external casing. Part number 5. So the housing forms the outer shell that surrounds the insulator and supports the insulator and installs the spark plug in the engine. Now you will see when you install the spark plug inside the engine, these are the threads. So there is a specific spot on the engine where these threads will be tightened up, and this works as the casing. Then part number 6, this part, glass seal mounted between the center shaft and insulator to maintain air tightness. A special mixture of glass powder and copper powder is charged in the installation section for the insulator and center shaft and the center electrode, and melted at high temperature. So basically this is for the insulation purpose, the glass seal. Then comes the gasket, this seventh part. There is a gasket over here, makes the housing and the engine fit tightly to each other and maintain the air tightness of the combustion chamber. So when this fastens up inside the combustion chamber, so there needs to be air tightness. There should be no leakage. So this gasket works as the leak proof. So then comes the part number 8, this part. This is electrode with copper. A special nickel alloy is used for the center electrode to reduce the electrode wear. Copper is sealed into the center section to improve the thermal conductivity. Then part number 9, you will see something here. Ring packaging washer. Again a washer that is used for air tightness and the proper insulation. Then a center electrode, part number 10. This center electrode, you will see. So this electrode is new iridium alloy tip with a diameter of 0.4 mm and is laser welded on the tip of the center electrode to make the center electrode. So then part number 11, this outer side, this is a U-groove ground electrode and nickel chrome material is used for it. And then comes the tapered cut ground electrode, part number 12, this. So this is the ground electrode that has the shape in which the electrode tip is cut to the finely tapered shape. So basically these are several parts of the or components of the spark plug. So in real or in actual, what we will see that there is a cable connected over here, and when you provide the circuit current, it will show some spark over here. So you will see that if you happen to remove this spark plug from the engine, and even if you keep it 1 inch away from your engine or chassis or any conductive chassis material, you will see that the spark is visible till 1 to 2 inches. What I'm trying to say is that when mechanic they repair your engine and they check for the spark, so the spark won't be visible if the spark plug is installed inside the engine. So they remove the spark plug and then they insert the remove the spark plug from the engine, and then they connect the cable of the ignition coil over here, and then they hold it with the hand, and then they just ignite the engine. From ignition, I mean to say that either they push the kick, press the kick to start the engine, or they press the self button to start the engine. So basically the engine won't start, but actually by touching to any conductive ground of the chassis or engine, since this is carrying some current. So if you just touch or even don't touch, if you keep it 1 inch away from the conductive part, you will see that spark is visible. So this is having this much of higher current. Now I'll show you a video that tells you the working of a spark plug. So this is an engine cycle that is the engine that is working, and you will see that the spark is creating the sparks over here. So this is a 4-stroke SI engine and this is a spark. So this is the place where the actual spark happens. And this is the center electrode. So this is the gap that is to be maintained. So if this gap is less, then there will be problem. If this gap is more, there will be problem. So this is the visibility of the spark that happens. So if the fuel is present, around this spark plug, there will be a blast. Otherwise, if you happen to see this spark, you can connect it in this circuit and you just press the ignition switch and you will see this. So the internal construction, this is the center electrode and this is the lower part where actually we were discussing it a moment ago. And this is how the spark happens. So we have this cylindrical arrangement of the engines. Like based on the cylinder arrangement, there are various types of the engines. Like we have inline engine, we have V engine, we have radial engine, horizontally opposed engine or opposed engine, H type engine, W type engine, and various other engines also that we have. But these are some popular things that are needed to be discussed. So inline engine is basically a configuration which will have multiple cylinders in inline. So they could be vertical engines and all the cylinders are aligned to each other. So this is inline arrangement or inline engine. Now in V engine, you will see that the cylinders are arranged in V shape. You will see that this is a V engine. Then this is radial engine. So radial engine is that these cylinders are arranged in radial manner. Then this is opposed engine. So this is basically horizontally opposed engine and you will see that the pistons are opposing each other. And this is H arrangement. So there are horizontally opposed engine and the pistons are connected with forming H. So we'll see how these various engines are working. So though they will be like, again, I'm telling this has nothing to do with the spark ignition or compression ignition. This is just the type of engine and you can have a spark ignition engine or compression ignition engine in these types. So we'll just show you the working. Don't go on the fuel type. So first we will see inline engine. Okay. So you see these are 4 cylinders and all the 4 cylinders are in line with each other. And these are the pistons working. So you see these are some intake and exhaust valves. And now if you happen to see, these are the cams and this is the camshaft. And these are the valve spring. And you see when this camshaft is rotating, this rotation of the cam and follower. This is a mechanism. So if you have ever heard or studied in your engineering, then you must be understanding this, that cam is designed for a specific operation, that it operates anything for a particular period of time for a particular duration, and for the rest of the time it closes itself. So you see, this is how rotation of cam is operating any valve. You see this. So this is your crankshaft basically. And the crankshaft is designed for every piston. So this is the inbuilt design of the crankshaft. And over here, the crankshaft is connected to the connecting rod and then to the piston. And this is how the inlet valves and springs and valve lifter, they are arranged. And then the camshaft are arranged with the cams. And then several timing belts are arranged and timing gears are arranged. So what is timing arrangement or timing system? The timing system is, it is designed for this particular crankshaft, that for what period of time and exactly when any particular valve is to open. So let's say cylinder 1 valve is to open. So when it is needed to be opened. So this timing belt or timing system, this is designed for the operation of these camshaft and for these valves. So this is how you will see that inline engines are working. So everything is in order now. you will see that the sparks are happening and the power is uniformly produced in this way. So this is an inline engine. Again, the intake, compression, power, every stroke is happening here also. This is the same thing that is explained again. Like first intake happens, then compression happens, then spark happens, expansion and exhaust. So intake stroke, the fuel comes in, air fuel mixture comes in. Then second stroke will be your compression stroke. In compression stroke, this air fuel mixture will be compressed. And then power stroke, this spark plug will produce a spark over here and this power stroke will happen. Power stroke happened and then exhaust stroke. So this valve will open up and exhaust will happen. See, now this has happened. So this is how this system is working. So irrespective of its fuel type and the CI or SI engine, these inline engines are going to work in the same fashion. So where can you find these inline engines? Usually in your car, in your bike, if they are multi-cylinder, so they will be inline engine, but not everything, not every car and every bike or every two-wheeler are having inline engine. Few are having V engine also. Then we will see what next thing is. Next is our V engine. Okay. So you see this is an animation which shows you the arrangement in V shape. So earlier pistons were having inline order. Now the pistons are arranged in V shape, and this is basically to minimize the area at the same time to maximize the number of cylinders. So this engine will be compact at the same time. It will be immensely powerful as compared to the inline engine. So this is the top view that is visible. Now this is the side view. See, this is how these pistons are going to be arranged, and the crankshaft is arranged in this fashion. And then these are the opening and closing timing arrangement for the valves, several valves. Then they could be timing arrangement, and you see this is how this engine is arranged. Now we'll go further and we'll see what type of engine do we have. Then we have the radial engine. We'll go for the radial engine, and mostly radial engines are used in the aircrafts. So this is an aircraft which has the radial engine, and you see this is how the radial engine works. So now this engine is running, and this is the cylindrical arrangement of the pistons. And this is how these are connected to the crankshaft, and then crankshaft is connected to the blade, and this is how this aircraft engine is worked. So again, same thing. Stroke, first stroke happens, intake happens, then second stroke happens, compression, then third stroke happens, power, and then fourth stroke happens, exhaust. So the strokes are same throughout, just the arrangement of the cylinders, it could be different. So this different arrangement of cylinder leads to different setups and different applications where exactly the engine is to be used. So if you use an inline engine inside an aircraft, it would be very hard for you to run the aircraft, as there will be issues with this power and the size of engine, and obviously the type in which the power is being produced. So this is radial engine. Now, again, we have the opposed engine. In this type of engine, the pistons oppose each other, and this arrangement is designed in such a way that the opposition of the pistons is connected to the crankshaft, and that crankshaft is being rotated by this movement of the piston. So you see these are 6 pistons connected to the same crankshaft, and the piston movement is opposing the movement of each other. Like you see, these pistons are movement is opposing. So this basically arrangement is known as horizontally opposed engines or horizontally opposed pistons. So this is how this engine configuration works. Then we have the H engine. So this is how these H engines are arranged. These are pistons, and then they are arranged with the help of the gears, and then they are connected to the crankshaft or connected to the output shaft, and this is how they are arranged. Okay. Then to deal with problems of the engine, the problem will be to supply fuel. How are you going to regulate the supply of the fuel? In spark ignition engine, the fuel is supplied by the carburetor, and now the injectors also, the injection systems also. But let us first understand what is the carburetor. So basically, carburetor works on the principle Bernoulli's theorem. So I hope you heard the Bernoulli's theorem. If not, then you please, after this session, you study about Bernoulli's theorem. So I'll just tell you. So let's say this is an intake and this is a venturi. So venturi is something where the diameter narrows down rapidly. I mean, instantly the diameter has reduced from here and again it increased. So this is a venturi, and the carburetor makes use of this venturi only. So basically a carburetor, if you can see this is a carburetor, and this bottom part, it has the fuel, and the fuel line is connected from here, from this part. The fuel line is connected. I'll show you the internal also. I know it won't be easily visible to you in the camera. Just okay, this height is sufficient. So there is a spring. As soon as you open up this carburetor, so the accelerator wire is going to be inserted in this, and through this spring, it will be going to this arrangement. So this is basically something that controls your fuel supply, and air is going to come in this carburetor from one place, and then there is fuel that is going to come, and this will mix the air and fuel mixture. And from here, from this point, the fuel will be coming into the float wall over here, and there are some float inside it which governs the engine fuel supply. And then this is the choke. Choke, I'll tell you what is choke. Choke is nothing but it makes when you operate the choke, it makes the mixture rich. I'll tell you what is rich mixture. And this is ideal screw, like limiting screw, ideal speed limiting screw. If you tighten it up and if you loosen it, so it will increase or decrease the amount of fuel supply or air fuel mixture. So there are few things. Before doing this, we will just see how things are working in the carburetor. Okay, so this is a venturi like this, and air comes in from here. Then there is a valve you see Just give me a moment. Okay. You see, this is a wall. So if I open it up, you must be seeing this is how your throttle is controlling this operation. So basically when throttle wire is attached, it will be attached with the spring like this, so that the throttle bounce back to its original position once the throttle twister is left. So you will see that this is how the supply is controlled. This is when you throttle up, you just open it up. And when you throttle down, you just close it. So this is how it is governed. Now, this is what we are talking about. Air comes in from here, and this is the base. If you see, this is the actual carburetor that I'm showing you. This is the airflow that comes inside, and this part is connected to the engine. So this is the exact carburetor that I'm showing you. Air comes in from this side, and this part is attached to the engine intake manifold. And this part comes over here, which is connected to your throttle or the hand twister. So when you operate the throttle, basically you open this position. So if you see it from this side, this will be opened up like this. And this is the base. And basically the float valves are inside and the fuel remains inside it. And the fuel lines are attached from here. From the here, fuel line is attached. So what happens? The air will enter from this side and the air fuel mixture will be mixing in this section and it will be going in the engine from this side. So obviously there will be several fuel filters before the fuel reaches the carburetor, because the fuel might have some particles, some dust or some any impurities inside it that can choke the venturi, or that can choke the orifice of the carburetor, because it is very fine orifice inside it, and even the dust particle comes in, then it will choke the carburetors. So a carburetor is a device that atomizes the fuel and mixes it with air. Atomizes means it actually activates the fuel with air after mixing it with air. So the carburetor have been widely used in SI engines as means of adding fuel to to intake manifold. The pipe that carries the prepared mixture to the cylinder is called the intake manifold. This one, intake manifold. And the carburetor is the focal point of the induction system, because it is everything starts with here. If the engine has the carburetor, then fuel system consisting the fuel tank, necessary fuel pump, lines, filters supply the fuel to the carburetor. So the point from where I showed you that the fuel goes inside the carburetor, before that you have a fuel filter, you have a fuel line, and the fuel is coming from the fuel tank of the vehicle. So during the motion stroke, vacuum is created. So basically when the piston goes downward, this is the cylinder and this is piston. When this piston will go downward, so let's say this is the intake manifold and over here is your carburetor attached. This, let's say, is the carburetor and this is the intake manifold. Okay. Now air is coming from here, fuel is coming from here, it is getting mixed over here in this area, and it is going inside the combustion chamber. Now what happens is the combustion, this piston, when it moves downward, it creates a partial vacuum over here, and that vacuum, I'm getting my voice back to me. Please mute yourself, whoever you are.
Excuse me. Hello.
Hello. Yes, let us continue. what will happen? A vacuum is created over here and this air fuel mixture will start coming inside. So this is what was written over here, that during the motion stroke, vacuum is created inside the cylinder, which causes the air to flow through the carburetor and the fuel to be sprayed from the fuel jets. So like this, air coming in, and over here from the fuel jet, the fuel is being sprayed inside the venturi, and then here itself the fuel will mix with the air, and you see this is the choke valve. So you see this button, no? You see this button, you see the same button over here. This is the choke valve. So what is the choke valve? Basically, this opens up this position in order to supply more fuel towards the engine. So when the engine is not starting up, you pull the choke, and the choke is basically letting more rich fuel coming inside the combustion chamber so that the combustion can happen quickly and more possibly. So when you throttle up, so you basically open this particular position more. So let's say this is, as of now, this position is as of now opened. So in the second case, when you throttle up, you basically are opening more area, more position. So this area increases, and then there will be a time when this position will be like this, like the flow can happen in this way, and then there will be a time when this is almost closed. So not closed, almost closed, but there is small passage left here. So when you pull up the choke, you basically let more rich fuel of air fuel mixture come inside the combustion chamber, and this is how it works. So this is the fuel in, like the fuel is coming inside from the fuel tank from here, then it will go into the float chamber, and this is the float valve, and then this is connected to the jet sprayer, and this is the venturi, and over here this is the this is the choke valve, this is the choke valve. So the choke valve, when it is opened up, it lets more air in and it makes the rich fuel mixture rich, and then it goes into the combustion chamber. So this is the choke valve, not this. Okay, so then due to the volatility of the fuel, most fuel vaporizes and forms a combustible fuel air mixture. Then the throttle plate located at the carburetor regulates the quantity of the mixture. And then there is a limited range of air fuel ratio in a homogeneous mixture within which the combustion sustains flame propagation. And the range of useful air to fuel mixture is approximately 20:1. This is for the lean mixture, and 8:1 is for the rich mixture. So there are two types of mixtures, where lean mixture and rich mixture. Lean mixture means where the fuel presence is less as compared to the air. So this is economic, and this is rich mixture. 8:1 means fuel to air quantity is increased. Like let's say there here we were using 1 ml of fuel, and over here we are using 1 ml of fuel for the 8 cc of air, and here 20. Okay, so this is how lean and rich mixtures are differentiated. Then there is a small video of the carburetor. You see, this is a carburetor. You see, this is the bottom part of the float of the carburetor, and this is the spring that I showed you, and this is the section that I was lifting or closing. You see, this is how air is coming inside, and over here at the venturi, now this is the narrow part. Over here at the venturi, this air is mixing up with the fuel. This is the choke valve, and the choke valve is opened at the time when more air is required, because more air will cause the combustion easily. And this is the throttle valve, throttle plate basically. So when you pull up the throttle, you basically increase the passage over here. So this is how your carburetor works. So now you see this, there is a pin needle basically here. This needle is inserted into this orifice, and from here, due to the vacuum, due to the Bernoulli principle, the fuel is coming inside this venturi. From here, as soon as you lift up the needle, the fuel will start flowing inside. You see, this is how this air fuel mixture is controlled. Like basically the air is same. Air is same. The quantity of fuel that we are controlling with pulling up this cable or this spring. So this is how your carburetor works. Now, after this, we have the fuel injection system. So fuel injection system is basically how the injectors work. Now, over here, I have the schematic of the CER DAI common rail diesel injection. Pre-injector, and there are the injectors connected, and these injectors are controlled with the electronic control unit or ECU. Then we have the high pressure pump, and from the fuel tank, this pump is connected, and this pump is drawing the fuel from the fuel tank and it is supplying to the common rail over here. And from the common rail, this injection, these injectors are having their fuel. And now we will see the internal of the injector. There is a electronic solenoid, and then there are some puppet valve, intensifier piston, check ball, nozzle assembly, nozzle valve, and basically a lot of components that allow the injector to spray a fine mixture or a fine fuel or atomized fuel, you can say. So what are the requirements of the injection system basically? So introduction of fuel into the combustion chamber should take place with precisely defined period of cycle. The metering or the measurement of amount of fuel injected per cycle should be done accurately. The quantities of fuel metered or measured should vary to meet the changing load and speed requirement. The injection rate should be such that it results in the desired heat release pattern. The injected fuel must be broken into very fine droplets, or you can say a spray. The pattern of spray should be such that as to ensure the rapid mixing of fuel and air. The beginning and end of the injection should be sharp and quick. The distribution of metered or measured fuel in case of a multi-cylinder engine should be uniform among various cylinders. So the functions of fuel injection systems are that to filter the fuel and to measure the correct quantity of the fuel to be injected, to maintain the time of the fuel injection, to control the rate of fuel injection, to atomize and break up the fuel to fine droplets, and properly distribute the fuel in the combustion chamber. Now there are a lot of drawbacks of carburetor. Though carburetor is still used in two-wheelers, but there are a lot of drawbacks of the carburetor. The drawbacks means there are some problems like choking of the carburetor and the fuel efficiency and the supply of unregulated supply of the fuel sometimes. So these are some, or efficiency you can say. So there are electronic injection systems that are coming into play even in the bikes also, even in the cars also, even if they are having the spark ignition engine. So I'll show you a small video of the injector and will tell how the injection system works. So these are 4 injectors, and this video will show you.
EFI systems use.
This video will show you that how these spray are happening. So this is a small nozzle. The injectors are fitted inside an engine, and you see this is how the spray is being done over here. So let's say this is a multi-cylinder engine and we need to inject the fuel inside the cylinders, and we will see how it will be done with the help of the injectors. This is where the injectors are placed, and this is how the spray happens. This is a spray of the fuel from the injector, and this comes inside the combustion chamber like this. as and when required. So it is controlled with the timing system, and it is electronically controlled also. It is controlled with the mechanical arrangements also. Then there are some issues in the petrol and diesel engines, and those issues are if we have unregulated fuel supply, if we disturb the timing system inside the combustion chamber. Like timing system means intake and exhaust. So suppose this is your spark plug and this is your engine, and intake is happening from here, exhaust is happening from here. So this is the combustion chamber, let's say this area. So there are some cycles happening. There are explosion happening. There are the gases present over here. So everything needs to be in perfect order. Like when intake is happening, there should be no gas inside it. And when the exhaust is happening, there should be no intake inside. So what happens on repeated usage of the engine, the total overall temperature of the combustion chamber increases a lot. And if the timing system of our intake and exhaust is faulty, this will lead into the detonation with knocking in case of SI engine, knocking, and in CI engine, detonation. So this knocking and detonation is nothing but an unusual phenomena which is harmful for the engine. So what will happen that in this particular condition, the of intake, exhaust and spark, it disturbs, it doesn't match. And compression. Mismatch of the intake, compression, ignition, and everything that will happen. So that causes knocking in the SI engine and detonation in the CI engine. And it is basically the resultant temperature of the combustion chamber. What's happening? It is basically the resultant temperature of the combustion chamber. It increases, and there is a time when it increases so much that even this could lead into the seizure of the engine. So I'll show you a video which tells the problem of the knocking, and similar problem will happen in the diesel engine also. So you see, this is the regular combustion. Everything is fine and everything in order as of now. Now, you see that the gases are passing right away, and as soon as these are passed up, intake happens. Okay, and this is working in regular thing, in normal thing. So what is knocking? Now, you see the timing is disturbed. The gases intake and everything timing is disturbed. Now it should be intake over here and spark is happening over here. You see, this should be intake over here, a spark is happening, and then this is the issue. So it is irregular fashion. It is irregular or abnormal thing. So this results into the mixture of the exhaust gases inside the combustion chamber with the intake. So when the intake happens, it should be a fresh one. It should not be mixed with the exhaust. But in knocking, the exhaust emission will be mixing with the intake, and this will lead into the disturbances into the normal cycle of operation, and this will cause into knocking. Now I told you what knocking is, and it will result into a lot of problems into the engine, like spark plug failure and failure of the valves. Like there is some material attached to the valves, and the valve timing affected. So you see, this is how this disturbs. So pre-ignition and knocking. So ignition happens basically a little earlier than it should happen. So these are the problems. Then we have the fuel pump left. The fuel pump is a part of fuel supply system or fuel delivery module. So what is fuel delivery module, or what is fuel supply module? Basically, it makes use of a fuel pump. Sorry, a fuel pump that is fitted inside the fuel tank. It has some fuel lines also. It has some fuel filters also. And basically, I'll read out the components for you. Fuel tank, where the fuel is stored, and fuel line through which the fuel comes into the combustion, into the injector or the carburetor from the fuel tank. And fuel pump is something that draws the fuel forcefully from the fuel tank. And fuel filters are to filter the fuel that is coming from the fuel tank so that no impurities go inside the injectors or the carburetor. Then fuel water separator. Yes, there are some instances when water has present inside the fuel tank, so there should be a water separator also. Then air filter also is a component of this fuel delivery system. So air before coming into the combustion chamber, it needs to be filtered so that there are no dusts, so that the combustion can happen easily and in more efficient way. Then there is fuel injection system that we studied just now. So we'll have this video to explain what is a fuel supply system or fuel delivery module. So it is mostly in the advanced engines when the supply of fuel needs to be in a very decorative way, in a very structured way. So you see, this is the interior of the fuel tank, and the fuel is now filling inside the fuel tank, and this is the fuel pump. So this is the sensor that displays the level of the fuel inside your fuel tank, and you see that this much of fuel is present inside your fuel tank. So now you will see that this is a center unit. Now from here, this pump is going to suck or take out the fuel from the fuel tank from this point, from the cursor. So this is a section view. This is a fuel pump interior part. So fuel pump is basically, you see these two wires. They are coming directly from the battery, and as soon as you switch on the fuel pump, this fuel will be starting to take the fuel from the fuel tank, and as soon as it is done, it will start sending the fuel tank fuel to the fuel lines and to the injector. So this is how it is going to work. Then this is the suction point from the fuel tank, and it is sending it to the fuel lines. This is how. Then some sensors are connected to regulate the fuel supply to the electronic system of the car. And these are the fuel delivery modules or the fuel pumps that are there in your CI engines and SI engines. So this is the fuel delivery system or fuel pumps basically. So now at this point of time, we are at a point where we know a lot of things about the internal combustion engines. We just summarize. If we summarize, we know the introduction to automobiles. We know introduction to two-wheelers, three-wheelers, four-wheelers, multi-axle vehicles, and chassis and body, wheels and tires, suspension system, brake system, steering system, powertrain, drivetrain, HVAC electrical system, and then classification of IC engine, then based on strokes and fuel type, and then engine components, and then the nomenclature, then four-stroke engine in SI, then four-stroke engine in CI, then two-stroke engine, then comparison of SI and CI engine, then comparison of four-stroke and two-stroke engine is left. I'll just read out for you. So the four-stroke engine, the cycle is completed in 4 strokes, and in two-stroke engine, the cycle is completed in 2 strokes. The turning moment is not so uniform in 4-stroke engine, hence need a heavier flywheel. And in 2-stroke engine, the turning moment is more uniform, so lighter flywheel can be used. And what is the flywheel? The flywheel as I explained in the morning session, the flywheel, as the power supply during these strokes is interrupted. So flywheel obtains its power or energy or inertia during the power stroke, and it delivers it to the crankshaft when there is no power stroke to uniformize the turning moment. Now, power produced for the same size of engine is less in 4-stroke engine as compared to the 2-stroke engine. Then lesser cooling and lubrication is required in 4-stroke engines as compared to the 2-stroke engine. Then 4-stroke engines have valves and valve actuating mechanisms for opening and closing of the intake and exhaust. However, there are no valves for the intake and exhaust of the 2-stroke engine. The piston governs that. So because of the comparatively higher weight and complicated valve mechanism, the initial cost of the 4-stroke engine is more, and it is less in case of the 2-stroke engine. The volumetric efficiency is more in 4-stroke engine as compared to the 2-stroke engine. The thermal efficiency is better in case of 4-stroke engine. Used where efficiency and emissions are priority. We are talking about the 4-stroke engine, and 2-stroke engines are almost outdated and they're out of use as of now. So after that, we had this spark plug, the cylindrical arrangement of the various types of engines, then carburetor, then fuel injection system, then fuel delivery system. So tomorrow we will have a session about the electronic ignition system, the ignition timing, noting and detonation. Noting we had today only, detonation will do it tomorrow. Then cooling system, air cooling, liquid cooling, and then clutch, and then transmission, then gearbox, then power transmission, differential. And so I hope this session has been useful to you, and I'm able to clear doubts, I'm able to teach you some new things. So I will just hand over this session to the moderator. You can continue. This will be all from my side at this point of time. Thank you.
Okay, so thank you, Mesa, for that wonderful session. So guys, that's all for today. We will continue with our sessions tomorrow, same timing, morning session from 10 a.m. and afternoon session from 4 p.m. So make sure all of you attend all our sessions and try not to skip any sessions. So thank you. So you can leave, all of you can leave now.